Welcome back, and we are in finals week, and this is going to be the last thing we're going to do, the last task, and it's going to be completing this final exam, and it's in front of you right now. You have four drawings that you're going to replicate, and you got to open all four of these. You're going to draw each part, and I think there's six parts altogether. And I want to help you just a little bit on this just to make sure that you understand all the different things that's in this drawing. And we'll get started. First thing I want to do is I've already opened these up, so I want to pull this open. And you see it is a clamp, and there's six components, six parts. And as of now, you should be able to assemble, and you should be able to make this drawing just as it is right now with the bill of materials, and also putting the balloons on here, and also filling out your title box. So this would be exactly what I want for the first sheet. The second sheet, you go into individual parts and you start laying those out as you see. And some of them have multiple parts, and that's okay, just as long as you have those identified on here. And of course the last one would be the screws. So I want to go through and I want to show you a few things that you might have some issues on. And let's start out with the first piece right here, and it's the clamp piece. And you'll notice it's going to have to be threaded. So let's get into that one and take a look at it. This is number one. Pretty much this is the front. This is or this would be the front. This would be the right side of it. You've got a counter bore hole here going through. Then you got a 10/32 tap through hole, and then you got a .312 hole right here that actually stops. It's a blind hole, it means it's going to stop into the part, and it's showing actually the drill point on this. And you can actually do that in the drawing. You put that drill point in there. And first, let's go in here and take a look at this. This 1032 tap hole all the way through, what that means is it's a number 10 drill, 10 diameter, and 32 threads per inch. So this is going to be threaded all the way through. Now, let's take a look at something real quick. This is a thread, a bolt, and if you look at it, every bolt has a major diameter and has a minor diameter. This is the root down inside of it. This is a crest on top, and then this is your thread angle. Your major diameter is what's going to fulfill this, the first little number on here. And you see it's number 10. Well, that's an actual size. Number 10 is. And it is, if I ain't mistaken, it's like 0.19 inches. But most of the time you're going to see like 1/8 of an inch, 1/4 of an inch, something like that. And then your threads per inch. But let's look at here. This is number 10. So I want to draw. I'm just going to roughly throw something in here real quick. And I want to show you what I'm talking about and how to actually put those threads in. It won't take me just a second here once this loads up. But I'm just going to throw something on here just real rough. And I'll just throw that on there like that, and I'll extrude it. Okay, something like that. Now I want to put a tapped hole all the way through this. So if I click on this, I have to go to New Sketch, and this is the best way to do it, is to use a point. Get that point on there, finish your sketch, and now you got the hole command. And inside that hole command, if you go in here, it's going to be threaded tapped hole. So you click on this and you come down and check that out. It's already on number 10. You all see that? And see here, when you get into this, you've got the different sizes of holes, and number 10 is just the drill size. 0.19 is the actual size. So I click on that and see how you got 1024, 1028, 1032. Well, 10 is the diameter, or that's just the drill size. 0.19 is the diameter. 32 is the threads per inch, and it's a unified national fine. Again, if we looked at this, what you would do is you're finding the threads per inch, and what that is you just put an inch ruler across here and count how many threads you have, and that's what you're getting. So 1032, it has 32 threads per 1 inch. Okay, now pitch, it'd be what would be from one point to the next point. Okay, so when we put that in here, 1032, 2B is the classification. B means it's internal thread. 2 is just the tightness of it, how either loose or tight it is. And let's get in here. And if you'll notice, I've got a countersink on there, and you're better off to have a countersink and just make it a little bit larger than that 0.190. And right here it says 0.210. You could probably even go 0.200, and it'll put that in there for you. Now, far as like going all the way through the part, through all, you all see this right here is a distance. This is through all, and you just hit OK, and see how it puts that thread in there for you. So that's what it's talking about, and you've got that thread. So that takes care of it. And let's go in here and look at one more thing on that drawing. You're looking at the depth of this hole right here. Do you notice it says 0.312 plus 4 minus 0? So whenever in the machine shop, when they make this part, 0.312 is the lowest limit that they have. So 0.312 diameter, and it can go up to 0.316. You're just adding this to it. So it has to be between 0.312 and 0.316 when we measure it. That's your tolerance. Okay? So when we get back in here, we're going to do a sketch on the top of this. I'm going to put a point, and I'll show you how to do that. You're going to use the hole command again. And on this one, it's just, of course, I like to use my chamfer just to have a little bit of chamfer on the end of it. It just cleans the burr off. We're going to be in a hole, a little bit of seat in that. And I come down here, remember it's a blind hole, so I've got a distance, and that distance is going to be, let's go in here and take a look. That distance is going to be 5/16. So when I go back to my drawing, this distance is going to be 5 divided by 16. Okay, it gives us a depth, and it might be more than my material here. I'm not sure. Yeah, my material isn't that thick. So let's cancel that real quick. Let me go back in here and make my material a little bit thicker. I should have made it to the exact size. There we go. So now I can go back to hole, catch that one. It's a hole. It's going to have that on it. It's going to have a distance depth of 5/16. Okay. It does have a drill point on the end of it. If I took that away, it'd be flat, but you're going to have a drill point on this one because it showed it. And this at the top is just a little bit too much. What is the diameter on that? We got to get that too. The diameter is 0.312. So I'll go back in here. Diameter is 0.312. 0.312 is the diameter. Okay. Up here, our chamfer is going to be, and you can see it's going to be outside that. I've got to fix this thing again. I'd do like 0.32 or something like that. And the rest of it should be fine. Hit OK on that. And what I'd have to do is I'd have to go back up here. I didn't make that exactly the right size. I got to edit my sketch. Let's make that a little bit bigger. And let's do that. I'll have to come off this edge right here. That should be fine now. There we go. We have some material now to work with. And you see how that goes in there? And it's got a little drill point on the end of it. So that would have number one. I think that would be all that you would have any trouble with on number one. Let's go to the number two part. And I don't know if I've got it up here or not. So let me go back to my blackboard. I've already got that one. It must be number three. Yep, right there is what I need. Okay. And again on this one, get to where I can see it really well. Anything that you'd have trouble on here that I'm looking at, again, basically no. I would set like the distance of this 1.938. I'd put it right on that money because you got plus or minus. That's your tolerance whenever they make it when you measure it. So it can be 1.943, or it can be 1.93. But just put it right on the number on that. You got a 3/8 24. So 3/8 is the major diameter and 24 is the threads per inch. But just use that point command that I just showed you earlier. And again, if we want to go back in here and put that in at 3/8 24, I'd have to put me a new sketch on this, point, finish, and then just do your whole command again. 3/8 24, whole command, threads. I do a little bit of a chamfer on the ends of it, and I'd come down here. 3/8 is 0.375. 3 divided by 8 is 0.375. And then you just come down here and adjust like if it's 0.38. We'll go point on the chamfer. We'll do like a 0.4. See what that looks like. And see, it puts a little nice little chamfer on it to get started. And 3/8, and what was the thread on that again? 3/8 24. So again, it's 16. That's Unified National Course, Unified National Fine. Right there you go. So we hit OK on that, and it looks great. So let's move on to the next drawing. And we are going to get into a screw. Actually, no, let's go back and let's see. So one's taken care of, and two is the screw, the screw. So let's find it. And right here's number two, and here's the screw. There might be a few things that you have some issues on. And you see right through here, you see the hidden lines. This is your thread. So you got 3/8 24 NF's National Fine 2 is the class of fit, and you got a chamfer on the end of this, and then you got a fillet up here on the top. So when I would do this, roughly, let's say I was drawing this thing out. It'll take me here just a second. So 4.5, and I come in here and I'll draw this thing, and 3/8, so it'd be 0.375. 3/8 is 0.375. That's your outside diameter of that. You see 3/8, 24. 3/8 is your OD diameter. So I'm going to divide by 2 because I want to revolve this, and I want to bring this thing back so far. And I'm not going to draw all of it up for you. I'm just going to just roughly put some of this stuff in. 5/8 is, and I'll show you what you do on the top here. And this isn't actually correct from what you guys are doing, but I would finish it, and I'm going to do a revolve. Catch that point, spin it around, and then okay. And this isn't exact how yours is going to be, but anyways, first I want to put I'll put a chamfer on this, or I can put a thread, either one. Let's go ahead and put a chamfer on the end. Whenever you're calculating chamfers for threads, it's always good to do this. Use a calculator, and you see that this has got 24 threads per inch. Well, if y'all remember back over here, I need to find the pitch. Okay, the chamfer is always going to be half the pitch at 45 degrees. So if you got 24 threads, you take 1, divide it by 24, and it'll tell you the distance between each thread. Between each thread would be 0.0416. Okay, so again, you take that number of the pitch and you divide it by 2. This is how that you do it, and you got a 0.021 basically. We'll round up. So out here on the end of it, we'll do a chamfer, and 0.021, and I'm going to use a 45 degree, so you can do distance angle. 45 is perfect, and I just click on that, and just like that I've got my chamfer in. The threads, pretty easy. Just come up here and hit thread. Whenever you click the face of it, it automatically knows that this is a 3/8, but it doesn't know the threads per inch, so I want to put 24. And that UNF, Unified National Fine, and they go up 3 1/8. Okay, so come here, location, not full length, but 3.125 is 1/8. And the thing of it is, you also got to remember that it's when you're doing this, it's probably going from that point right there, not this point. So you got to minus that 0.021 that we had in there. So it just shortens it up a little bit. Okay, so it takes care of that. Now on the top of this thing, and mine's not right. I mean, you can see that. But I'm going to come up here, I'm going to double click my sketch. That's way off, so I need to measure it. And we're looking at that should be 5/8. So 5/8 is 0.625. We took 5 divided by 8, and then I divided by 2. It really gets it down there. And what I would do on this, it doesn't give us any specific, it's just kind of rounded. Like it says there, it really doesn't have a dimension on it, so I'm just going to rough that in. I would start somewhere. If this is the total length of it, just like you're seeing, I'd do a 3-point arc. I'd come down in here just a little ways and come up to here. And you see where it hits tangent, and I'd trim it out. That's totally fine because they didn't give you any dimensions on that. And then when you finish it, it'll kind of roll it over like that. Okay, that's all I would do on that. Okay, let's see, number 3. Let's see what you might have trouble with on that one. Number 3 is the butt head screw. Slot it. It's 1032. It's this little guy right here. And you can just draw that if you want it to. It's 1032 by 5/8, so it's 5/8 inch long. That's a 1032. And when I draw that up, I would just do something like this. I would come in here and 5/8, 0.625, and we know it's 0.091 or 0.191, so 0.191 divided by 2, and I'd come back here all the way out and catch that, and then I'm just gonna roughly put that up there, and we'll just you can get a machinist handbook and just draw these, but these screws you can buy. You can buy them so you don't really have to reinvent the wheel and draw them out. Now there is a content center in this software, and I'm just kind of doing like we did before. There is a content center in here that you can actually pull out like screws and threads and things of that sort. So I'm going to shoot that on up there. If it doesn't, just delete it out. Bring that line back in here. Bring it in. Finish the sketch out. Zoom in there. And we're going to revolve it. Okay. And I didn't give enough material on this thing up here to put that. So, I mean, you can go back and fix that. I don't like the way that looks. And we're just eyeballing it. So it's not really that important. I just want to get the 5/8 inch or the length of it correct. So there's an error somewhere in there. But anyways, let's just move on just for the sake of time. And let's go ahead and get this down here finished up. This was 5/8 inch long. The bolt is, and let's see on the chart, 1032. So go up here and hit a thread specification. You just click on it. It automatically should bring up specifications, and this should be a 1032. So go over here and find your 10, and it should be a 32. And we're just going to have it thread the whole way. And we're throwing up an error. And probably what's going on here, if I go in here and check that out, having a lot of errors. This should have been 0.190, so 0.191 divided by 2, so that's perfect. So we shouldn't have any trouble with that thread going on there. It's looking for 0.190, so that might be the difference. Let's go in here and check that out. That might make a little bit, that little bit of difference might make a world of difference on here. Let's see. And want a 32 thread. Isn't that crazy? 2 thousandths made the difference, but very smart software. And again, make sure you do your chamfer at the end. Remember what I taught you. Use your calculator. So you take 32 or 1 inch divided by 32 times. Divide that by 2. That's your pitch. Divide by 2. About 16 thousandths. So this would become 16. Come down here, click the face of it, and click the angle. And there you have it. And of course, you need to fix the top of it. Mine looks pretty shabby there. But there would be your thread. Okay, so let's move on. The washer is pretty straightforward. Now the clamp, number 5 is the clamp. And let's see if there's anything on there that might trick you up, because that's not what we want to do. Again, on this one, 3/8 tap through. Again, this is 3/8 diameter bolt that's going to go through this, and it's got a 24 threads per inch, just as I showed you already. There's 2 times. That means you got 2 of them. I think we're okay. And then, of course, here's your tolerance. This is 1.938. That's exactly what you need to put it on. This is just at the machine shop after they get done making this. It has to be within this tolerance. Plus 5 thousandths add to this, or minus 5 thousandths away from that. And then number 6 is going to be the last threaded screw. And again, it's kind of like the one that we made a little bit earlier in here. Let's take a look, see if there's anything on here that might trick you up. The chamfer, okay, it's got a chamfer. Let me pull this up here real quick. You all see right here the chamfer? Just make this a 45 degree. Just make this 5/16, and then just put yourself a 45 degree angle on there. I'm not worried about the distance or anything. Just start from there, put that 45 up, and it'll be fine. This is all threaded back through here, as you can see. And 3/8 is your outside diameter. So that would be from the top to bottom. Here's 3/8 of an inch. 24 is your threads per inch. It's the national fine. Do it exactly the way we done the number 2 screw. The fillet on the top will do it just like we did the number 2 screw. Just eyeball it in. I'm not worried about that. It's just smooth. Don't worry about this knurl on here. Don't worry about that. Just make it smooth for now, and just whenever you're in your drawing, just make note that this will be knurled, medium knurl, and that's just roughening up so that you can get grip on it when you're turning it, just like tools have on them, metal tools. Let's see what else on here. And on the very end here it says 3/16 radius. So it's roughly just taking and doing a 3-point and going from here to here and bring it out 3/16 radius. And I'll show you what I'm talking about there. Let's just say we're going to do that to this one right here. So I go down here and find my sketch. And we're going to zoom in. If you hit F7, it'll cut it in 2 for you, which really makes things cool. Hit it again, it takes you back. Well, I can't do it, it's threaded. So what I want to do is I'll make myself a new sketch. I'm just showing you how to do this phase of it. And say, for instance, this is 0.311 diameter, 0.311 diameter, finish sketch. I'm just going to extrude it out, 5 divided by 16, and I went a little bit too far. That's okay. Let's say I want to put that little rolling there, okay? This is how you could actually do this. I'm going to use that plane right there and make myself a new sketch. Okay, hit F7 to cut it in two. And what I want to do is find the center of this thing. Right there it is. And I need to get that line straight. So line, and come back. It says 3/16, 3 divided by 16th. So if I were to put a circle in here and put it coming up 3 divided by 16 times 2, because everything's on diameter on this thing. I want to take and move this to where it looks right. Okay, that right there. No, that should work out pretty good right there. And then I'd take my line and catch that point, come up here, something like that, catch that point, trim out what I don't need, finish sketch, and use your extrude, do a cut, catch it, cut both directions, and that won't work. We have to do an actual revolve. So we got to revolve half of this thing around. So F7 again. I got to go back in here into my sketch. F7 to cut it. And we'll make a real quick fix on this. Trim. Boom. Let's get rid of all this junk we don't need. That's all I need. And this time, let's do it right. Let's revolve it. Instead of extruding it, cut. Profile is this. Axis. And I don't have an axis line. So I've got to put myself an axis in there. So first, cancel out, hit axis, click the diameter here. There's my axis now. Revolve. Make sure you're on cut. Click your profile. Grab your axis. If it's not showing it to you, just click on axis there, and it'll do it, and hit OK. And you can see now how it puts that little ball nose on the end of it. And basically that's going to be used in here as it pushes, so that it doesn't have a whole lot of friction as it turns. Okay, so those are a few little tips that might help you on this exam. If you have any more questions, just please holler at me. Thank you.